Hello students, let's read the question. So this is the theoretical question in which first part we need to explain the meaning of a statement electric charge of body is quantized. Quantized, what it means. So in first part, so the electric charge of a body is always quantized. So this is the statement. So what does it mean? So the electric charge of a body is quantized. It means that only integers like 1, 2, 3 up to, let's say, up to n is the infinity number. These numbers of electrons can be transferred from one body to another. Like we have the formula for charge, that is Ne. Q is equal to Ne. So Q is the charge, N is the integer or the integral multiple. So this is the integral multiple with electronic charge. So this integers may be, let's suppose, 1, 2, 3 up to n. Now as this E term here is the fundamental unit for the charge of an electron. So E for electron, so this is the value is minus 1.6 into 10 to the power minus 9 coulomb, and for proton this E term is positive of 1.6 into 10 to the power minus 19 coulomb. So in other words, we can say that the charge on any object is always an integral multiple of the elementary charge. So this integer, so what we conclude, this integer number, so this integer, this is the important term, so this will be either positive, negative or 0. It can't be in a fraction. So we can write this: charges cannot get transferred in fractions. Like fractions like 3/5 or 2.6 or minus 1.9 or 0.2. This is the fractions value. So this charge transfer cannot be transferred in fractions. Therefore, we can say that the total charge possessed by a body or the object is only integral multiples of electric charge. So we can say a body can have charge. So the body can have charge like one integral multiple like 1e, 2e, plus 3e, or the plus 2e, or minus e or 1e, minus 2e, minus 3e, but it cannot be fractionalized charges. Like fractionalized means fractional charges like 1.5 E or minus 1.5 E, 4.6 E or minus 7 by 3 E, this not be possible. Only this like this is possible. Now next for second part. So why can one ignore the quantization of electric charge when dealing with macroscopic or a large scale charges? So macroscopic is known for large scale charges. So to answer this, on the macroscopic level, so for microscopic level or scale, can say this as a scale that is considered for large scale. So the number of charges used is too much than the magnitude of electric charge. So as in macroscopic system, so the total charge involved is typically very large as compared to the elementary charge, electric charge. So the difference between these levels becomes negligible when dealing with such a vast number of charges. So as a result, we can say that, or we ignore the quantization of charge in macroscopic level, and we consider quantization is considered insignificantly in a quantization, or we can say that quantization of charge is a perfect is considered insignificant at a macroscopic scale. For an electric charge, and electric charge are considered quantinous. So this is, we consider the quantinous charge on the macroscopic level. Also we can continue this, we ignore for large scale system, and for this is due to enormous number of charges involved. In simple language, we can say this, we can ignore as the for large scale system due to enormous number of charges involved. So this is the required solution. Hope you find the video useful. Thank you.